Okay, example 7 says, how long does it take $4,000 to grow to $12,000 at 10% annual interest rate, compounded continuously, round to the nearest year? So now, we did continuous compounded interest in chapter 6.2. And if you recall, the formula for continuously compounding interest is the final amount of money in our account equals the original amount of money in our account times e to the RT power. In fact, I think I used P. So it'll look like the word PERT. The principal, what we're investing, times e to the RT power. R is the interest rate as a decimal, T is the amount of time. We're going to keep it in there. And in the problems that we did in chapter 6.2, I told you how much money we were investing, what the interest rate was, and how long we were keeping it in, right? And we had to figure out the end amount. Well, this time, the reason I use that formula in particular, because it says compounded continuously, so I'm using the compounded continuously formula. Then I start looking through the problem to see what it is I know. $4,000 is what we're investing. It's growing to $12,000. That's what we're going to end up with. The interest rate is 10%, which is what R comes from. R is not 10, but it's 10%, so you have to change to a decimal. And the question they're asking is, how long will it take? How long does it take? We're looking for time. E is the number E that we've been working with all this time. So if I start substituting what they've told me into this problem, we're ending up with $12,000 after first investing $4,000. That's being multiplied by E to the 0.10t, because 10% as a decimal is 0.10. We're investing at a 10% interest rate for an unspecified amount of years. And we're trying to make $4,000 become $12,000. Notice the structure of this equation. It's an exponential function. It is exactly the issue we dealt with on Friday, where we have e to a power, but we have a number in front of e to the power. So my first priority is I want e all by itself. I don't want a number attached to it, so I'm going to divide both sides by 4,000. $12,000 divided by 4,000 happens to equal the wonderful number 3. If it divides nicely, go ahead. If it doesn't, leave it as a fraction. Like if it was 12,000 over 7,000, that does not round to a nice pretty number, so then you'd keep it as 12,000 over 7,000. You can reduce it to 12 over 7. But don't try and make it into a decimal. Keep it as a whole number or keep it as a fraction. It's more accurate. That equals e to the 0.10t. Notice I've left a little bit of space here on both sides. Okay. Once I have e to a power equals a number, what do I want to do? I'm going to ln both sides. I'm going to natural log. Natural log, because base e is the natural log base, I want the bases to match. So natural log of 3 on the left equals natural log of e to the 0.10t on the right. I chose particularly natural log here because if this is base e and that is base e, the power is the outcome. What? ln.
Oh, sorry.
My pen's not registering all the way through my writing there. Sorry about that. So ln of the left equals L on the right. Again, base e logarithms because it's a base e power. Okay. So base e, power comes out. My calculator knows the natural log of 3. Type in ln 3 equals, and it spits out all those decimal places. I'm going to write them all down. So 1.0986, 12289. And if 1.0986122289 equals 0.10t, how do I figure out what t equals? Divide by 0.10. So divide both sides by 0.10, and that gives me 10 equals, or t equals 10.986122289.
Could you tell me the number again?
1.0986122289. So if I do that divided by 0.10, you'll see that it just moves the decimal point one space to the right. So 10.986122289. Okay. It says round to the nearest year, so that's how many years, 10.98 years. So if we round to the nearest year, it should take about 11 years. Just a heads up for your investment purposes, what we did was we tripled our money, right? We had 4,000, 4,000 times 3 is 12,000. If I had $4 million in 11 years at a 10% interest rate, I'd have $12 million. It doesn't matter what these numbers are. If I take that divided by that, that's what I did to the money. So if it's 4 million, 12 million, 4 billion, 12 billion, 4 trillion, 12 trillion, when I divide, I get 3 every time. It still takes the same amount of money to make the money grow by 3 times as much. So that's just an interesting little fact there. But again, when you don't know t, but you do know everything else, it's just an exponential function we're working with. We solve it using that technique. Okay, make an exponential function out of it, and then use the techniques we used on Friday to solve the exponential functions.